So let's look into the DEVS atomic model. So previous slide sets that I explained the basic concept of the DEVS formalism, and now we are looking into the details of it. So DEVS atomic model is basically the bottom line of your modeling abstraction. So the atom is the most small the element of the natural object, let's say, and then atom is not much divisible by keeping its the materials properties, right? And this is it. That this DEVS atomic model is now a state transition model that is not going to be divisible any further within your modeling framework. So this is going to be the basic building block of your model. Okay, and so here is a set of states, and of course the set of states are being defined as S. Okay, so here we have S, a set of states. And this, if once we define the state, we have to define its transition. So S is being defined, and in traditional, previously like Moore machines, finite state machine, or serial automatas, transition machines are what? Are only taking the external transition. Okay, the external transition is an event transition coming from X, right, and coming from S, and then it creates what? It creates the transition of the next time into the S, right? Right. So X and S is coming in, and next time S will come out. That's the external transition functions, right? Right. And here, S and internal is coming in. Internal is another transition function, and internal transition function will first here will be invoked. How? S will coming in and will define time advance. And once the time advance from 0 to R, define the time advance value. Once the time advance is being completed, and then we'll be invoking internal transition functions. Delta internal. And this delta internal will call S for the internal state transition, and its next state will come up from delta internal. Here, it's not like the X external event. This delta internal is only taking S because it is invoked by the timer, not by the external event. Okay, so it is a timeout event. Okay, right. And the next element is this. So you have to define the time advance function. Okay. So state will determine the time advance so that eventually we can call internal if the timer is out. And now, previously, the transition also defined the output. Okay. However, now we have two outputs. Output 1 from the external, delta external, and transition 2, delta internal. So that there is, now we have a demand to separate out the output functions. So here, output function is what? The lambda. And this lambda will be called when it is being the timeout is done. So that here, once the timer will invoke the delta internal, and the same timer will invoke what? The lambda output functions. So that output will be spit out when the timer is being timer is being going off. Okay, so that's the lambda function, which is an output function. So this whole together will constitute DEVS atomic model. state is being defined, input and output is being defined. Input and state together will create the external transition, and state and the time advance function will create the timer, and once the timer is done, state will be transitioned by the internal state transition, and once the timer is done, then lambda will be called and output will be generated. So now let's define the DEVS atomic model's formal definition. We will create atomic model as an AM, right? AM, and it is being made of 1, 2, 3 variables, and delta external, delta internal, output function lambda, and time advance function, and 1, 2, 3, 4 functions. So 3 variables and 4 functions. Okay, very simple. X is a set of input event, Y is a set of output event, and S is a set of states. Okay, simple. And delta external, mathematically, it is a combination of state and X. Okay, so this multiplication will define the combination. Which combination? One instance of S, one instance of X. Okay, this will create a one instance of state for the next time. So that is an external transition function. Internal transition functions will take current S to the next S. Okay, and that is the internal transition function, right? Right. And the lambda here will take current state S and will create an output of Y, right? An output function. Finally, time advance. Once S is given, it will create a time advance timer, and the timer will take continuous value of the time advance. How much time will be by self-initiating internal transition, and the time will be from 0 right now, or otherwise infinite. Okay, we don't know when will be the next internal transition. It's like a dead model if we set the R to be infinite. Why is that? Because otherwise others invoke something, request us something. I'm going to be completely deaf and alone, and I'm not going to self-initiating any behaviors. That's the mode of R infinite, of the time advance function. Okay, so these are the mathematical the definition, formalism of the 3 variables and 4 functions tuples. All right. And now let's represent it as diagram. Okay. Here we set S to be state, right? And this state will declare how much time will take in this state. So this is a time advance function, right? Right. And then we have to have a transitions to be specified. And one transition is the question mark of X. Question mark is asking, query from outside, right? So that X is being called upon as an external event, so that S is going to be making transitions. So this is the external transition. Similarly, there is another transition coming in from this state to this state. Here, however, we have an exclamation mark, okay? Exclamation mark and the Y. So it means that while doing this transition, I'm saying out loud that it's going to be Y. So that this is an output specification. And this output will only come out when the timer is done. When the timer is done, also there is an what? Internal transition. So that internal transition and then output specifications are done at the same time with this single arrow. Because, why? Because those are the simultaneous function results. Okay? Now it's being done, and let's move on to the other cases.